So I know that we've kind of talked a lot about interfaces, but I wanted to take a step back and actually talk about them from a fundamental level, and not so much from the in the code and how you use them, but more of why you use them and what the benefit is. When we first started using them, we were kind of in this space of, let's create a class and then we create an interface and then we create another class. And some of you have said, well, what's the point of doing all this class and interface work? And it seems a little unnecessary. We could probably just do it by just building a class and being done with it. And that's absolutely true. You could just build your classes, do what you need to do, and be done with it. And the way that I was explaining it, or the prior understanding that I had from some of you, was that you knew about interfaces maybe from a prior course. So I want to take a step back again and talk about, from an architectural level, what is the benefit of using interfaces? So the diagram that you see in front of you represents kind of what we've ended up with at this point with our code. You've got your presentation layer, which is where your Windows Form app lives. That's just form 1. That could be any form in theory. Then we have our business layer, which is kind of our core library of what we're doing. And inside of there, we have our interface, which is our iInventory utility. We have our class, which is our dependency injector. And then we have two utility classes. One is the static inventory utility, and one is the DB inventory utility. And then we have a data layer at the bottom, which is our SQL database. And everything's all kind of jammed together, and that was honestly done for simplicity. I was trying to not make you create projects and projects and projects, but that's not really a real world scenario of what you would see happen. Instead, what we should have done is something that looks more like this, where you have that business layer core piece of functionality which defines your interface and your dependency injector. And your dependency injector could even be in its own class library, but typically they kind of work together. So we have our presentation layer at the top, and then we have this larger, more complex business layer. In that layer, we have a core for our business layer that includes the interface and the dependency injector. We then have separate class libraries for each one of our iInventory utility implementation. So here I've actually done two implementations. One is a database-based implementation, which is what we've done in our video lectures up to this point. And then there's a secondary one, which is connecting to a web service. And depending on which piece of functionality we end up using, maybe we're migrating from a database inventory utility into a web service utility, we implement separate class libraries. And then the dependency injector is the piece that has the logic that picks up and gives us the appropriate inventory utility that then gets presented up to the presentation layer, and then ultimately we present that data. Now, with that in mind, you may be thinking, well, how does this really work? Because you still kind of have everything in the same business layer together. And what happens in a true world scenario where you may end up having things that are a little more dynamic or loosely coupled? Well, this architecture allows us to build a plugin infrastructure so that we can actually allow either ourselves or our team of developers or even third-party developers to build functionality that extends our application. And by utilizing these interfaces, we don't really care how that implementation is written, as long as it matches that contract of our interface definition. So those methods and those properties that we define in our interface, those become vitally important, because the only way that that presentation layer at the top can talk to that database is through this inventory utility interface. So these layers that I have stacked the way they are, they're stacked that way intentionally because the presentation layer only sees the core. It doesn't actually see the SQL implementation. It doesn't actually see or know about the web service implementation, and it doesn't know about the data layer below it. The goal is that if you take out or change one of these lower layers, that the Windows Form app doesn't need to be modified in order for that to work. It simply knows that I have an interface that I'm talking to. There's an interface that I'm interfacing with, quote unquote, and I rely on the dependency injector to get me that appropriate implementation. So let's look at kind of an even more real-world example where maybe we're using more of a plugin approach. So what I have here is probably a more real-world scenario. We have our presentation layer at the top, which is our Windows Form app. I've called out the app config, and I'll talk more about that in just a moment. But what I've done is I've actually separated out the core class library into its own kind of layer visually. And that's to help show an even greater level of separation. And then we have some business layers that we've created, which is our SQL and our web service layers. And then we actually have a plugin layer or component that's been added as well. So when you think about this, what's happening is that the Windows Form application is going to only be looking for this business core. It's not going to be looking for any of these bottom third layers, and it's definitely not going to be talking to the data layer. And the goal here is that we have this plugin component here, and if we can take it and make it so that we can plug in and take out different pieces of functionality depending on the data layer that we need to communicate with, then the Windows form never needs to know about it. And the only place where that happens, where that decision is made, is in the dependency injector and the configuration of the application itself. And that's where the app config comes into play. So let's say that we have that call to our dependency injector from our Windows Form app. So we call to the dependency injector. The dependency injector then looks to the app config and says, which class library do I need to look to find my iInventory utility implementation? Well, inside of our app config, we say you need to look for the abc.cp.nosql class library. So for that would be this plugin layer. So the dependency injector would actually go and fetch the NoSQL inventory utility class, create that instance, and then present that to the Windows form as the interface that's implemented. So then when we make our calls from our Windows Form application, those calls go through the interface. We're talking to the interface, right? But really behind it in that memory address is the NoSQL utility. So then those calls go to the NoSQL utility, which has the implementation of the actual code for how we connect to the NoSQL database. And then it connects to the database itself and communicates appropriately to that data. Then if we needed to make a change to maybe the version of our code, or there's different deployments, we would make that change in the app config. No compiling is required. We simply drop in the appropriate DLLs into the folder. These business or class libraries turn into DLL files, so we just put the appropriate one with our executable. We make the app config change, and then our application is able to serve different types of data layers and business layers. So this is really more of what a real functional application at an enterprise level that's pluggable, modular, would really look like in that separation of concerns. I don't want to have to go back and modify my presentation layer every time I decide to change my data layer. That becomes a lot of work, and then I have to release new versions every time. If you've ever been in a business environment, or maybe even at home, where you had an application that used one type of data layer or source and then it changed to a different one, or even if you were using maybe like a game, when servers change or services change, or you add plugins for additional functionality or add-on packs, they're using this same architecture to facilitate that work, because those add-ons probably implement interfaces that are predefined in the core of the game, and they're utilizing that interface and dependency injection approach to be able to bring in those add-ons. So this is what happens in a lot of different applications, and this is what makes them flexible and expandable, is to utilize this type of interface modular plugin infrastructure.